Alrighty. Here we're going to do something that we've kind of already done this before, I'm pretty sure, but we'll do it again. We're going to find the circumcenter of a circle, of a triangle, sorry. Circumcenter of a triangle. And the circumcenter of a triangle is a point that is the same distance from all three corners of the triangle. And it happens to also be the point of intersection of the three perpendicular bisectors of the triangle. And the reason why that kind of makes sense is because I've drawn this triangle in here. Every point on the purple line is the same distance from B as it is from C. All these points. If I'm anywhere on this line, and I could travel to either C or B, and it'd be the same distance. And the pink line has all the points that are the same distance from A as they are from C. So if I'm on the pink line, I could travel to C or to A, and it'd be the same distance. So specifically right here at this point, I could travel to C, or I could travel to A, and it would be the same distance, or I could travel to C, or I could travel to B, and it would be the same distance. So the distance from this point right here, because it's on both lines, I could travel to B, or to C, same distance, or to A, same distance. Right? I could travel to any three of those points, same distance. Also, something to think about is that I could draw a circle through that point, right? And a circle is all the points that are the same distance from the center of the circle. And so if the center is right here, then B and C and A, they're all going to be on that circle because they're all the same distance from the center of the circle. That's why it's called the circumcenter. Okay. So we're going to go ahead and find the actual coordinates. I mean, I've drawn it and you can see it as 0, 0, but it's just a fluke of this problem. But we are going to write the equations and find it. And we're going to go through it by first finding the equations of these two perpendicular bisectors, finding their point of intersection. We're not going to do the third perpendicular bisector. We're just going to verify that the third corner is also the same distance. That all the corners are the same distance. So let's go. First, we're going to find, and by the way, I've labeled this first perpendicular bisector as line M, so it's a lowercase m, and the second one as line N, right, lowercase n, which is just convenient because sure, there are other points on this line, but they're not terribly important. And since I don't want to label 2 points on the line, I'm just going to give the line itself a small lowercase letter name. Right? So that's fine. Let's see. Let's do, first of all, slope of M. Okay. Now the slope of M is going to be the negative reciprocal of the slope of BC, which you can just look at it here, and it's 1, 2, 3, 4 over 2. So the slope of BC is negative 2, so it's going to be positive 1/2. And then midpoint of BC is, and we could go through the midpoint formula here, but you can just see where it is 1, 2, 3, 4 up 2. It's the 0.42, and again, we could calculate that using midpoint formula, but I'm just going to kind of skip that. So our equation is y equals mx minus h plus k, y equals 1/2 x minus 4 plus 2. So y equals 1/2 x, negative 2. Oh, it's just going to be, that's it, 1/2 x. Okay. Next, we're going to find the equation for our second perpendicular bisector, right here. So this is going to be slope of n. Now, if you look from A to B, the slope is down 3 over 9, so it's negative 1/3. So the slope of n needs to be positive 3 over 1, or 3. It passes through the midpoint here, which midpoint of AC, which again we could do all the calculations, but it's 0.5, 1.5. So it's 0.5 comma 1.5. So I'll write our equation here. I might write this as 3/2, 1/2. Maybe that's better. Okay. So our equation is y equals our slope, which is 3x minus 1/2 plus 3/2. Okay, so that gives us y equals 3x and this is minus 3/2, because when we multiply 3 times 1/2, it's 3/2, minus 3/2 plus 3/2, so it's just going to be 0 again. Well, plus 0. So our two equations for our two lines are y equals 3x, y equals 1/2x. So let's find the point of intersection. So we've got 3x equals 1/2x. And I mean, you don't have to do a whole lot of work here. There's only one number in the whole world that I can multiply by two different numbers to get the same answer, and it's 0. So x is 0. All right, so the x coordinate for our point of intersection is 0. And then we'll just go plug that into one of the two equations, like this one here. Y equals 3 times 0. So y equals 0 as well. So the point of intersection is 0, 0. Okay. So coming up here, if we were to find the perpendicular bisector of this last line, it should also pass through the point 0, 0. But we don't actually have to prove that, I guess. All we really, or if we don't have to find that equation and go through all this rigmarole again, we can simply show that this point is the same distance. We already know it's the same distance to from as A as it is from C, and it's the same distance from B as it is from C. So I mean, it should be the same distance to all 3 points. We'll just double check that. So I'll do AC first. Or I'm not sorry, AC. Let's call this point F. Right? So FC. Oh, that's a pretty easy one. That's just 5 units. Just count spaces. FA. And we could use like a distance from the thing, but since it's 0, 0, then using Pythagorean theorem, we're just going back 4 and up 3. So FA squared equals 4 squared plus 3 squared, but we should recognize this by now. It's that 3, 4, 5 triangle. So FA equals 5. I mean, you could go through and actually do the math yourself, but we've done this problem 1,000 times by now, so you should recognize it. For up to B, right, the distance from F to B, again, just Pythagorean theorem, over 3, up 4, and there's that 3, 4, 5 triangle again. So FB is also equal to 5. So it's the same distance from point F to A, B, and C. So again, that point is called the circumcenter. It's the center of a circle, right? Because the circle is just all the points that are the same distance from the center of the circle. And so if I were to draw a circle that had a center at point F, I could draw it so that it went through A, B, and C, right? Circumcenter. And it's also the point where the 3 perpendicular bisectors all meet. And because the 3 perpendicular bisectors are all the points that are, the same distance from any pair of corners of the triangle. So for example, segment or line M here has all the points that are the same distance from B as they are from C. So if I'm anywhere on line M, I could travel to B or C, and I'd be the same distance to go either way. If I'm on line N, the pink line, it's the same distance for me to travel to A or C. It doesn't matter. And if I happen to be at point F, which is on both lines, then I could travel to A or C or B, and it's the same distance every single time. Okay? Circumcenter.